Friday. Okay, let's do this. Unit 5, Lesson 2, Solving Systems by Substitution. Okay, so for this lesson today, what I did was I picked a few questions from eMathInstruction, and I also am using a few other questions that are just more practicing the skill rather than going into word problems and getting crazy. Okay, for homework / classwork, instead of doing it in the textbook today, I attached for you a worksheet. So again, that's just a little more straightforward practice instead of having you guys get confused and then telling me that you don't know what you're doing in the comments. So we're going to just do some straight up practice with this, and you guys let me know how you like that, and if you prefer worksheets like this, then we'll do that going forward. Okay, before I begin, I just want to make a few reminders, make a few announcements and give you a few reminders that every day when you log on to Google Classroom, that daily agenda that I'm posting, you have to all read that, okay? Even though it seems like it's the same thing every day, make sure you read it, because sometimes there's different things in there. I need you guys watching these videos. I need you answering the opening tasks. Some of you are still not turning in the opening tasks and you're just posting them in the comments. You have to turn it in. If you're not sure how to turn it in, ask a friend, please, someone else in the class or someone in another class, or anybody really who's in one of my classes, because there is a button or a way that you turn it in. I can't see the view from mine because mine is obviously on a teacher setting, but so I can't see where the turn in button is or whatever it is you need to do. So make sure you ask somebody, because if you don't turn it in, when you comment, it doesn't tell me that your work is done. So even if some of you are commenting on the posts that I make, that's even worse. So please try to make sure that you're actually turning in the work. If you do the work, do a private comment, attach your work, all of that stuff, but then you don't turn it in, it gives me a hard time about grading your work and returning it to you. Okay, so please try to figure that out and try to do that every time with the opening tasks and the homework. Okay, all right, let's get started. Okay, so we're going to start off with the eMathInstruction lesson, and then I'm going to give you some problems that are not in the textbook, okay? So make sure you have either some graph paper or loose leaf paper or something to write those on if you did not print out this PDF. If you printed out the PDF, you'll have everything right in front of you, okay? So there's a whole bunch of ways we can solve systems of equations. In the previous lesson, we learned how to do it by graphing by hand. You can also do that in the calculator, which I'll show you in a few lessons. And the other way is to solve it algebraically. Okay, so there's two algebraic methods that are generally used, and the first one is using substitution. Okay, so for other students in Algebra 1, this is a review because you learned this in 8th grade, but since most of you did not finish the 8th grade curriculum, this is going to be new. The good thing about substitution is that it's the same exact thing as regular substitution. So the idea is you have two equations in the system, right? Just like yesterday. The difference is that one of them is going to be written in y equals form and the other one's not, okay? Sometimes they're both in y equals form, and we'll see an example like that. What we're going to do is we're going to use substitution to plug it in, right? So if y is equal to x minus 3, we're going to replace y with x minus 3. And it's very simple, but the calculations can get a little much. So we're going to just start off here. He wants us to show that 4, 1 is a solution to the system. So we're going to just prove it first. Remember, this is x and this is y. So what we're going to do is we're going to plug in 4 for x and 1 for y in both of these and show that it's a solution. So 2 instead of x, I'm writing 4 plus 1 instead of y is equal to 9. So that's 8 plus 1 is equal to 9. 9 equals 9. Huzzah! And now we're going to check the second one. Instead of y, I'm writing 1. instead of x, I'm writing 4 minus 3. 1 is equal to 4 minus 3, which is 1. We're good. Okay, so since it's a solution to both of these, it's a solution to the whole system. So now, he's walking us through the substitution process. So what I'm going to do is I'm going to rewrite it for you. 2x plus y equals 9, and y is equal to x minus 3. He's walking us through it. He wants us to substitute the x minus 3 in for y. And then we're going to show that the point is still a solution. So what he's saying is, take what y is equal to and replace it here. So 2x plus, instead of y, I'm using x minus 3, is equal to 9. And now we're going to show that the point 4, 1 is still a solution. Before I do that, I'm just going to take care of these like terms here. 2x plus x is 3x minus 3 is equal to 9. So now let's take that point 4, 1. Remember, x was 4, y is 1. And we're going to replace it here and show that it's still true. 3 times 4, because x is 4, minus 3 is 9. 3 times 4 is 12, minus 3 is 9. And of course, 12 minus 3 is 9. So you can see that it's still a solution. Okay, so now what we're going to do is we're going to solve the system by finishing the substitution. So what the heck does that mean? So we substituted in, we had 2x plus y equals 9, and we had our y was equal to x minus 3, and we were substituting, instead of y, we were replacing that with x minus 3. So that was 2x plus x minus 3 equals 9. So when he's saying finish the substitution, we're going back here and we're going to actually solve it. So the first thing I did was I did 2x plus x, because they're like terms. Remember, there's a who's so skinny, you can't see it 1. That's 3x minus 3 equals 9. And now what we're going to do is we're going to solve for x. Okay? So I'm going to add 3 to both sides. I want x by itself. And I get 3x is equal to 12. Okay, and I'm going to divide by 3 on both sides. And x is equal to 4. Now, if you recall from yesterday, the solution to a system of equations is not one point, right? I'm sorry, it's not one value, it's a point. So, as we said before, we already know what the answer should be. It should be 4, 1. So far we know we're right, because x is supposed to be 4. How can I find the y? Well, to find the y, what I'm going to do is I'm going to go back in, and I'm going to pick one of these equations, whichever one looks easier. So I'm going to go with this one, okay? Y equals, it was x minus 3. And I'm going to replace the x with 4 to find y. So y is equal to 4 minus 3, y equals 1, okay? So that was the solution. Now I'm going to walk you through it with steps in the next example, a little bit nicer, okay? But this is the answers to the first exercise. Okay, so here we go. I'm going to give you a few steps off to the side here so that you can do this on your own if you need to. Okay, so for substitution, first thing you do is you look and see if one of them is equal to y or x, okay? In this case, they both are. You're going to replace the variable with what it's equal to. Okay, and then in parentheses, I'm going to write if both are y equals equations, then set them equal to each other. And I'll show you what that means. What I mean by if they are both y equals is like this. Both of these equations are already in y equals form, so we can substitute either way, but what you're really doing is setting them equal to each other, okay? Step 2 is going to be to solve for that variable. Let's say the first variable, because it could be either one, it could be x or y, it's usually x. Okay, solve for the first variable. Then once you find that variable, you're gonna get an answer, x equals 1 or y equals 2. Then you're gonna plug in the answer back into one of the original equations, and you always want to go with the easier ones. One of the original equations to find the other variable. And then, guys, you're done. The last step is that you want to write your answer as a point. Okay, so if these steps don't make sense yet, don't worry, because we're going to go through it all together. Write your solution as a point, and of course that's x comma y. Okay, so these are our steps. First, we're going to replace the variable with what it's equal to. If they're both y equals, we set them equal to each other, or if they're both x equals. We solve the first variable. Once we get our answer, we then plug that back into one of the original equations, the easier one, to find the other variable. And once I have my x and my y, then I write my solution as a point. Okay, so let's follow the steps to do the first one together. So step 1 is to replace the variable with what it's equal to. If both are y equals, set them equal to each other. So since they're both y equals, I'm going to set them equal to each other. But the reason why is because if I was going to substitute this, look where it goes. It goes right in that spot. So they're just going to be equal to each other. Okay, so this is going to be, let me adjust myself here. Okay, this is going to be 2x plus 5 is equal to negative 3x minus 10. Just doesn't want to focus today. All right, and then we're going to solve, step 2, solve for the first variable. So what's my first variable that I have here? X. I'm going to solve for x. So remember, if you have variables on both sides, you want to try to get them over to the left if you can. So I'm going to take my negative 3x and I'm going to bring it over by adding 3x. Okay, and I go over to the other side, match it up with the variable, and add 3x. 2x plus 3x is 5x. Bring down the plus 5 is equal to, and what's left here is this negative 10. Remember, that minus sign is really a negative that's attached to the 10, so you have to bring that down. Okay, I need x by itself, so I'm going to use inverse operations. I'm going to subtract 5 from both sides. Remember to use your calculators here. I'm left with 5x is equal to, same signs add and keep, that's negative 15. And then finally, we're going to divide both sides by 5 to get rid of this coefficient. I need x by itself. What I do to one side, I must do to the other. So x is equal to negative 15 divided by 5, which is negative 3. Okay, that's not my answer. That's just x. So now that I've solved for my first variable, I go to step 3, plug it back into one of the original equations to find the other variable. So I'm going to pick the easier one. I like the first one better. I'm going to use the first one. Y equals 2x plus 5. And I'm going to replace the x with a negative 3 so I can find y. Y equals 2 times negative 3 plus 5. So y is equal to, this is negative 6 plus 5. Again, use your calculators, guys. Negative 6 plus 5 is negative 1. So now I have y and I have x. So step 4 is write your solution as a point in x comma y. So x is negative 3 and y is negative 1. So as a point, that's negative 3 comma negative 1. That's my solution. Okay, and that's how you do it. So I'm going to skip over part B, just trying to make this video a little bit shorter, but I included in here 3 different practice problems from another worksheet that are just a little bit simpler than what Kirk has in our textbook. So we're gonna do these to practice. I'm gonna do 2 of them, and you guys are gonna do the last one, and then you can check your answers, okay? So follow the steps. First thing is that we're gonna pick the one that's set equal to a variable, right? So that's the x equals 5. And I'm gonna replace the x with a 5 in the second equation, okay? So we're substituting. Plug it in, plug it in. Okay, so instead of x plus y equals 12, I'm gonna write 5 plus y equals 12. And I'm gonna now solve for y. I have to get rid of that 5. It's positive, there's no sign here, so I'm gonna do the opposite, subtract 5. What I do to one side, I have to do the other side. I'm left with y is equal to 7. Okay, now your next step is to take your answer and plug it back in. Now I can't use the first one here because there's no y, so I have to use this one. Okay, so I go to the x plus y equals 12, and I'm gonna replace the y with 7. So instead of y, I'm gonna write 7. So this is x plus 7 equals 12. Okay, I subtract the 7 from both sides, and x is equal to 5. This is a nice and simple one. Okay, so I have x is 5 and y is 7, so my solution as a point, x comes first, 5, comma, 7. Okay, if you wanted to test yourself, check yourself, you could plug in the values here and see if it's true for each one, okay? All right, guys, we're gonna skip over this one because it actually doesn't have a solution, and I didn't realize that when I wasn't thinking when I put that in here. I didn't want to confuse you guys, so we're gonna skip over this one, okay? We're gonna go to this one. All right, so, I can't ink my paper. Since both of these are equal to y, you can think of it as substituting one in for the other, or you can just set them equal to each other, okay? So, this is negative 4x plus 2 is equal to 6x minus 8. You guys know I like to bring them over to the left even if it's going to be negative. So when you have 2 variables, I bring it to the left, subtract 6x on both sides. Negative 4x minus 6x. Remember, you can always just pick up your calculators and do negative 4 minus 6, which is negative 10x plus 2 is equal to, and that negative is attached to the 8, so that's negative 8, okay? Keep going, subtract 2 from both sides. I'm left with my negative 10x is equal to negative 8 minus 2 is negative 10. I gotta divide both sides by negative 10, okay? And x is equal to negative 10 divided by negative 10 is positive 1. Okay, so I have my x value. Now I'm gonna go back in and I'm gonna use the nicer equation. I'm gonna use the second one just because there's no negatives, but you can use any one you want. Okay, and the point, remember, is to find y. So I'm gonna go y equals 6x minus 8, and instead of x, I'm replacing it with 1. Y is equal to 6 times 1 minus 8. That gives me y equals 6 minus 8, which is negative 2. Hooray. Okay, and now I'm going to write my solution. Oh, dear God. I'm going to write my solution as a point. X comes first, x comma y. So 1 comma negative 2 is my solution. Ta-da! I am adding on an extra example because I realized in the lesson there was none that involved this type of a problem where we're gonna, when we substitute, we'll have to distribute. It's just really important to go over that with you. So for this one, we have the y equal to 2x plus 1. So we're gonna substitute that in here. The whole thing has to go in there. So like we always do when we substitute, we have to put parentheses in. Okay, so instead of y, I'm using 2x plus 1. Okay, and then you rewrite the rest of the equation. So plus 3x equals 23. So this is what I wanted to show you. Sometimes, and a lot of times actually, when you have to substitute, you're gonna end up needing to distribute here. You can't just get rid of anything. Remember, married, single, do not mingle. So in order to do anything with this 2x plus 1, you have to distribute the 2. You gotta get rid of the parentheses first. So 2 times 2x is 4x, plus 2 times 1 is 2, and then plus 3x equals, whoa, 23, good heavens. And then from here you continue to solve. You would do 4x plus 3x is 7x, plus 2 equals 23. We subtract 2 from both sides. We get 7x equals 21. Divide 7 on both sides, and x is equal to 3. Okay, then we go back in and find the y. I just wanted to quickly show you an example of where you had to distribute. Okay, guys, because that's probably going to be on the homework, and it's, if there's one on the Regents, it would be more like this than the other ones that I showed you. Okay, that's that. So to finish up, guys, I did include exercise 4 because you do have all the skills necessary to do this, but this has already taken a lot longer than I intended on it. So what I'll do is I'm going to write the 2 equations for you, and then if you'd like to try exercise 4 to solve it, you can go ahead. On the Regents exam in the part 4 question, which we will practice later on, you're always going to have to write the 2 equations yourself. So this is good practice anyway. So we have 2 cell phone plans that are offering different text packages. The first plan is a $5 per month charge, along with a charge of 3 cents per text. Plan B has no per month charge, but it charges 10 cents per text. So they want us to figure out when the 2 plans cost the same. And you're gonna determine the answer by setting up a system of equations. Okay, so basically this is gonna be for 1 month, okay? Imagine that it's 1 month. It's one thing we probably should have said. So in plan A, let's just use Y, and T is for text, okay? So it's a $5 per month charge, $5 for the 1 month, and then after that it's 3 cents per text, so that'd be 0.03 times T. And then plan B doesn't have that monthly charge, it's only 10 cents per text. Okay, so in order to figure this out, these are your 2 equations. You guys can solve it by substitution, and they want to know, is there a certain number of texts when they'll cost the same amount? So what that means is you're going to set them equal to each other and figure out what the number of texts are where they'll be the same price. Okay? All right, guys, make sure you read the daily agendas, make sure you upload and do the assignments by turning them in and all that fun stuff. Your quote-unquote homework is on a worksheet today, okay? So make sure it's on the daily agenda attached. Oh my God, attached. And you only have to do 1 through 6, all right? It's also, by the way, not due until Monday, so you have the whole weekend if you need to. All right, guys, have a great weekend. I hope you're not going crazy at home like I am. Bye-bye.